Okay, so this is the second piece. This is where we're working problems. So I have put a few documents out there for you um, in following the time value of money lecture, the abstract lecture that I just went through. So these tables, all right, um, these tables are going to be fair game for the exam. And actually, let me say what I'm actually want to say. You'll be provided with, or you can print these tables to use for your last exam. All right, they're going to be important for us, particularly in Chapter 10 when we're pricing bonds. All right, uh, and so I referenced tables B1, B2, B3, and B4 in the lecture. These are those four tables. All right. B1 present value of a dollar, B2 future value of a dollar, and then B3 present value of an annuity of a dollar, all right, and B4 is future value of annuity of a dollar. All right, so we'll work through how to use these. The other document that you'll see is this practice set. So I'm going to do a couple of these and I'll post the solutions to the rest. For our purposes, however, skip number 4. I haven't deleted it, but that's not something that we'll need in chapter 10. So I'm going to work 3 of these and I'll post the solution to the rest. You can go back and work through them. I encourage you to do that to make sure you are able to work through these, right? There's a relatively focused area of content that we're going to need to get from this chapter. So this is what we'll do, and then we'll move into chapter 10. All right, so I'm going to work 3 of these in this lecture, and then I'll post a solution to the rest, so you can work through them on your own. So let's get at it. All right, let's start with number 1. Company needs to have $200,000 in 4 years, and will create a fund to ensure that the $200,000 will be available. If it can earn a 7% return compounded annually, how much must the company invest in the fund today to equal the $200,000 at the end of 4 years? Okay, so we'll need to. So I like to think of time value money problems as variables. Let's see. Excel wasn't doing anything and it's froze. Let's give this a minute and see if it comes back. Okay, so for question 1, the question is asking for what we invest today, i.e. time 0, to have $200,000 at the end of 4 years. Okay, so we have our, I like to think of it as a list of variables, and I'm going to shorthand. PV is present value. That's what we're solving for, all right? I is going to be interest, which is 7%, an annual rate. N is for the number of periods. In this case, that corresponds to years. It may not always be years. We'll get to that. And future value is $200,000. All right. So really, the answer, the question is, what do we need to invest today to have $200,000 at the end of 4 years? Well, so let's take these variables, and since we're solving for present value, the relevant table is B1, right? And the interest rate corresponds with the column. So 7% for 4 periods, right? And so the periods are in rows and the interest rates are in columns. So we get 0.7629 as a factor. And then to solve for future value, and I'm sorry, that's present value. It's just the future value times the factor, the 0.7629. All right, so there's your answer. The present value is $152,580. So that's what you need to invest today, earning 7%, to have $200,000 in a bank account at the end of 4 years. All right. Question 2, I think, is similar enough. So let's go to question 3. All right. So we're over here. A company has $50,000 today to invest in a fund that will earn 7%. How much will the fund contain at the end of 8 years? All right. So again, we'll start with these variables. $50,000 today. Interest rate of 7%. 8 years in term. And we're solving, in this case, for future value. All right. Well, the process is similar, only now since we're solving for future value, we're going to use table B2, right? And that's the most difficult part, is using the correct table, all right? So once again, interest rate corresponds with the 7% column for 8 periods, all right? And so we see 1.8385, all right? Future value equal to present value times 1.8315. All right. So $50,000 invested today, earning 7% for 8 years. At the end of 8 years, that account is going to be worth $91,925. All right. So that's how that works. Let's do one more, and as I said, I'll post the solutions for the rest, except for number 4, we're skipping. Let's look at number 5. All right. So reading it, a company borrows money from the bank by promising to make 12 month-end payments of $27,000 each. How much is the company able to borrow if the interest rate is 12%? All right. So again, we'll have variables, but we'll need to add one because in this case we're dealing with an annuity. PMT, which is payment. All right. And how much is the company able to borrow today? This is a present value of an annuity question. All right. 27,000 is the payment. Now, this is for monthly payments. All right. So the thing to remember here is when a problem gives you monthly payments or even quarterly or semi-annual, we need to make an adjustment. All right. So 12% interest rate, but you're making 12 payments each year, monthly. So instead of using 12%, we're going to use 1%. All right. Okay, and also this problem references 12-month end payments, which is 1 year. Right? If it gave you payments in a year, we would want to divide by or multiply by 12 to get to 12 periods. All right. This one gives you payments in month, but if it gave you the year, we would need to divide. Well, I actually multiply the year, 1 year times 12. All right, to get there. Future value, we will just say 0. All right, it's not relevant here. All right, present value of the payment times the factor from the table, which we can pull off. Now we want to make sure we're looking at the right table. We're solving for present value, which is table B3. And we know we're using B3 because it's an annuity, which means there are 12 $27,000 payments. All right. So we're going to look at the 1% column for 12 periods. All right. And that works out to 11,251. Okay. So the bank would be willing to lend you $303,887.70 if you were willing to make 12 monthly, end of month $27,000 payments. All right. So that's the present value of those future payments is $303,887. Okay. So that's how we work with the tables there. And that's it for now.